The first distribution that we're gonna look at in this unit is a uniform probability density curve with parameters A and B. Basically what it is a horizontal line that starts at A and stops at B, right? Uh, Now we know from if it's a density, a probability density curve, that means that the total area under the curve should be 1. So if this side of a rectangle, because the area is a rectangle, right? So this side of the rectangle is going to be B minus A, and that means that the height should be 1 divided by B minus A in order for the total area to be 1. Now, the notation is like this. X follows a uniform distribution. U stands for uniform with parameters A and B. These parameters basically tell you where this line starts and where it stops. And, you know, as an extension of that, it also tells you the height automatically. So we understand it intuitively. The wider our rectangle is, the shorter the height should be, right? So what is the height of this rectangle? Well, it's going to be 1 over 2 minus a negative 1. So it's going to be 1/3. So the height of this rectangle is 1/3. So let's use this distribution to find some probabilities. What is the probability that x equals exactly 1? Well, as with any continuous variable, that probability equals to 0. Now, what is the probability that x is less than 1? Well, 1 is right here. And intuitively, we can see that this is 2/3 of the entire rectangle, right? So it's going to be 2/3. But just for the sake of it, let's calculate it. So the width of this rectangle is going to be from -1 to 1. So that's 2, right? But we could write 1 minus a -1 multiplied by the height, which is 1/3. So this is 2/3. Okay, what's the probability that x is less than 0? Well, for the less than 0, it's gonna be this rectangle right here. And visually we could see that it's 1/3, but let's calculate it formally. Okay, so again, it's 0 minus a -1. So that's width multiplied by the height, which is 1/3. So that's going to be 1/3. Okay, now what's the probability that x is between 0 and 1? So again, it's this piece that's composed of the bigger piece that we already found minus the smaller piece that we already found. So it's going to be this piece, the x is less than 1, which equals to 2/3. And we're going to subtract this piece, the probability that x is less than 0, which is 1/3. So the result is 1/3. And finally, what's the probability that x is greater than 1? Well, it's this area, which is the complement to the probability of x is less than 1. So we can find it. We could also apply, find the area of this rectangle, or we could apply the complementary rule, which I prefer. So this is a complement of x is less than 1. So it's going to be 1 minus 2/3, which is also 1/3. So that's how you use um, a uniform probability density curve. Now, we won't always be able to find the mean and standard deviation of any probability density curve, but with uniform probability density curve, we can find the mean and the standard deviation. So the mean is always going to be the center point between A and B. So it's the average of the endpoints. That's for the mean. And the standard deviation is going to be the difference between A and B divided by the square root of 12. So let's see. Let's find the mean and standard deviation for this distribution that starts at -1 and ends at -2. So the mean of this distribution is going to be -1 plus 2 divided by 2. So that's going to be 1/2. So if we look at the graph, 1/2, it's right dead in the center between -1 and 2. As for the standard deviation, I actually want to correct this formula because written as is, it's going to be it's going to give us a negative number because B is a value on the right, which it is always greater than A. So I'm going to rewrite it as B minus A. This way we get a positive value divided by the root of 12. So let's take a look what we're going to get. So it's B is 2 minus a -1 divided by the root of 12. So I have 3 divided by root of 12. And 12 is can be root of 12 could be simplified as 2 roots of 3. And we could also simplify it, rationalize the denominator by multiplying the top and the bottom by the root of 3. And we're going to get 3 roots of 3 divided by 6. And then also simplifying 3, we're going to get 3 square root of 3 over 2. So that would be a standard deviation for this uniform distribution.